there are a couple of parts. So if we go over to the page in the manual that shows, I just had it here last night, where'd it go? It shows all the parts that are band specific. Piece of paper. It fell on the floor. It's got dirty, filthy footprints on it. So in the case of we had on the band module, we did the C1, 2, 10, 11, 12. What we didn't do was D3, and D5, which are band specific. Now D3 is right here. D4 is right here at generating 5 volts for the microprocessor, and he showed it change to 4.7 when you go to 20 meters, and I think that's a bunch of hooey. I think so. I kitted it with 5.1 for all bands. So I did not kit it as something you change. With the little rest of the parts. Here's, I got the baggie with the rest of the parts for that we didn't use on the band module. And there are 3 diodes here. I'm having trouble picking them up. And I know I'm going to have trouble reading them. So I need to get out my stronger light. And I wish I had a better pair of eyes to read these with. Boy. Okay. Can I get out my other magnifying glass? Now my problem is, not only do I need more magnification, I need more light on it to read. Now that I can. Okay, so this is a This is a 5231B. So 5231B is a 5.1 volt Zener. And we are going to use that in the power supply, generating the 5.1 for the microprocessor at all times. We don't care about changing it for band like it says in the chart on the old Rockmites. This is a new Rockmite, and I say we don't change that one from band to band. We leave it at 5.1 and let her go. And over here is the other one, D3. And D3 does change, supposedly, from 5.1 for 80, 40, and 30, and 6.0 for 20. So I'm going to get another 5231 because we just built this thing for 40 meters, so I'm going to make sure I got another 5231. Yep, there's a 5231B. And I am going to put it in 2 of these SIP sockets. So I'm going to cut the SIP socket with my handy dandy pliers. I'm going to go right in between the 2 and cut a tour off like so. And here's my 5231. I'm going to cut that down a little bit. I'm going to leave enough height to be a handle. And then I'll put that in here. Yeah, I can't see through my fingers. Okay, so now I got that to mount in where it says D3. So I will put that in D3. I will hold my hand on the top of it to keep it, and I will bring, I can't touch my iron holder because the iron's been resting on it all this time and it's going to be hot. It is hot. So I'm going to wander it over here. Now I can see it right on the edge, so I got to get a little bit more solder. And I'm still holding it with my finger. I don't know if you can see that. I'm turning it all over. I'm holding it with my finger. I'm trying to keep it nice and square to the board, and I'll just do one of the two. Let it cool. Make sure I like it. Yeah, I don't think I have to worry about it tilting or anything like that. It looks pretty good. And then I can solder the other one in. Where was it? Oh, up on here. Right there. Solder the other one in. And let that cool, and I'll go over here and I can see I missed this guy. I didn't miss it, we just added it. Okay, and then I'll go and I'll just reflow that second one. The first one I put in, I'll just reflow it to make it sure that we have a good solder. That was kind of wonky when I had to feed it with the iron, all that kind of jazz. So see, now you can pull that out and put it in another one if we deem necessary. I did put a place over here for a ground, so I can take the longest lead I've got. If you want to debug this, or you got a RF probe or something like that, and you want to be able to clip a ground lead or a test lead or something to it, it's always handy to have a ground loop that you can. So I'll just put a cut-off lead in there. Leave enough so you can get an alligator clip in there. I'll hold it, spread it, and then solder that ground loop on. Okay. Cut the leads off. Okay, I'm going to go all the way down here. I got pot, LED, switch, jack, pot, nothing there. Whoop, I got an R17 that's missing. And I got the capacitor, the transistor. Those two are okay. So I am missing R5, that's the volume, 1 meg volume thing that we don't use. So I've got to put R17. I missed R17, so I go back, look at the list for R17, and I see that is a 100 ohm resistor. Remember that lowly 100 ohm resistor I had laying around? There it is. So I just found it in my junk bin. So if you're going down the list and checking things off as you did them, then we would have caught this a lot earlier. But I caught it when I finished the board and said, hey, there's some holes there that don't have a part in it. Come on, where's my solder? Okay. So, connectors, jacks. Okay, we still got that transistor put in. We don't do L1, we don't do C14, we don't do R5. And everything else is there. So all we got to do is get that transistor in. So here's our our 3866 house branded transistor, and I'm gonna advise you, because the whole idea about building a kit being your own, you know what you got, you know what you're doing, but also you can experiment. That's the fun part. So I always like to build fun parts in the kits. So here I'm going to take this SIP socket and I'm going to cut 3 SIP pins off of it. And I'm going to take and put them onto the pins of the 3866. Okay, so now I can put that, I get the proper orientation. There's the little tab. The little tab is over here on this side. So that's the right way to put it in. It's reasonably bent to the right thing. I put the pins in, socket pins in. Having a hard time with the third one. Come on. Okay, there. I got them in. So I can do the same thing. I can hold that transistor in there with my finger, and I can see all 3 pins. I'm going to bring my thing up with my pliers because it's hot. I'm going to weight my iron down, so I'm going to turn this upside down. I'm holding it reasonably straight up in the air, and I'm going to come in and hit one of those pins and solder just 1 pin. So all I need is 1 pin, and there they are right there with those 3 pins. I'm going to go for the middle one. Okay, I got it. Okay, now I can flip it over. See, that thing's not going anywhere now. So I can just flip it over and make sure that I like the orientation of the 3 pins is good. I'll solder those connectors in. Well, the socket pins, they're not really connectors. I'm going to give them just a hair extra solder for mechanical reasons, because now you've got a plug that you can plug in and out your final transistor. Okay, and you probably want to shorten those leads up a little bit, so I'm going to cut it down a little bit. I'm going to try to cut it so they're all nice and square, so it doesn't lean off into the distance. And I can plug that thing back in. It should fit those socket pins pretty good. Come on. Okay. Whoops. I rotated it 90 degrees. Let's try that again. Get those pins so they look good. And there. Okay, so it's probably a little bit too short now. There is a heat sink in the mechanicals bag, a little top hat that will go up there, but we haven't really pushed it that hard to really worry about too much about that. But anyway, so the only thing we have not done is the impedance matching transformer down here that matches the transistor to the low profile or the low pass filter. I'm sorry. But this is everything from the discrete package. Okay, other than the ICs, and I can where the little foam thing with the ICs go. So the one with the little this says usually it has a piece of fingernail polish on it, which is the mic, which it says to me I programmed it with the code. That's the keyer chip. So